Okay, so here are some examples that I've drawn of some moving objects, representing them with vector diagrams over here on the left. First example, second example, I want to give you guys a moment to see if you can try to sketch the position time, velocity time, and acceleration time graphs. All right, I'm going to go ahead and show how I'm going to work these. This first example is very simple. Remember, you're always asking yourself, where does the object start and what is its velocity like? So it starts at a position of 0, right here. And it looks to me like every second it's moving 1, 2 meters. 1, 2, 1, 2. So I know that it's going 2 meters per second. That would be the velocity. I'm not even worried about numbers here because I just asked you to sketch. And that's a constant velocity. What's the shape of a position time graph if the velocity is constant? It's just a line, no curving at all. And so I know that the velocity is constant. I know that the velocity is a positive number because it's moving to the right. So the position is going to increase steadily as time goes on, a nice straight line like that. The slope is the same everywhere. The slope is one value. The velocity does not change. This is a straight line. So my velocity graph, I just need to sketch the value as time goes on. The velocity does not change. It's going to be some positive number. We calculated it was 2 meters per second. Positive 2 meters per second. It's always moving 2 meters to the right every second. So what's the acceleration graph going to look like? I don't have any acceleration at all. My object is not accelerating. The velocity is not changing. The slope of this line is 0. It does not have a slope. There is no rise. It does not rise or fall. There is no change in velocity over time. So I'm going to graph this just at the 0 point. The acceleration is 0. Let's look at the second example. I always want to think about where the object starts. This time it starts far away from the origin, and it goes back to the origin. So I know that the velocity is negative because it's moving to the left. And what's it doing as it moves to the left? It looks to me like it starts out slow, and then it speeds up. So I know that it's going to reach the origin. So I know it starts off with a shallow slope because the velocity is small, a small negative velocity to begin with. I know that it's going to end with a steep slope because it ends with a large negative velocity. So I'm going to make a curve that's getting steeper and steeper and steeper and steeper as time goes on, something like that, half of an upside down U, opening down. Small negative slope going to a large negative slope as the object approaches the origin. It's speeding up in the negative direction. So my velocity here, remember, positive and negative with velocity tells you direction. This object is moving back into the left. The slope of this is negative. And is it getting more negative or less negative? The velocity is increasing. The steepness of this position time graph is getting steeper and steeper. It's increasing. So I have an increasing negative velocity. So I'm going to start it out with a small negative, and I'm going to go to a larger negative like that. Remember what I said earlier in this class, we're not going to have any curves on the velocity time graph. So this says that the slope of this line is changing. The velocity is changing. It's a negative velocity, all negative, but it's getting more negative. It's speeding up in the negative direction. It's getting to be a larger and larger negative number. Now let's think about acceleration. Acceleration is the slope of this velocity time graph. Well, think about this. The velocity time graph has a negative slope, does it not? It's going down, and it's going to be one number, one negative number. So my acceleration is going to be one negative value. So one negative number, the acceleration does not change. How do I know the acceleration is negative? Once again, I can recognize that acceleration is the slope of this graph. This graph is going down, so the acceleration is negative. It has nothing to do with the fact that my velocity is negative. I'm just looking at the slope. What direction is this velocity line going in? Remember, up here my velocity line didn't have a slope. It wasn't going up or down, so acceleration is 0. Here it's going down. It's getting more and more negative. It's decreasing, going down and to the right. So my acceleration is negative. That's a negative slope. Why was my velocity negative? Because the position was decreasing. The position is going from 10 to 9 to 7 and then back to the origin. So the position is decreasing. It's going to the left, negative velocity. This object, once again to review, starts out far from the origin, goes with a small negative velocity, speeds up into the large negative velocity. So I start with a small negative velocity, speeding up to a large negative velocity, a negative acceleration. Once again, this makes sense because we know that if velocity and acceleration have the same sign, if the signs agree with each other, then the object is indeed speeding up. Negative, negative, the object should be speeding up, so this all makes sense. Okay, what if I asked you to look at these position time graphs over here, look at the velocity time graphs over here, and match them up? Which position graph matches with which velocity graph? I'm going to give you a moment to do that. All right, let's look at this first one. This is the only object that changes direction. So I can see here that for the first part of its journey, remember I recommended sometimes it's easier to split this up into two. For the first part of its journey, it's increasing its position, going forward, going to the right. Its position is getting larger. And then it turns around and its position gets smaller. And right here, where it turns around, the slope of that line is 0. So I need to have a velocity that in the middle of its journey goes through 0 and changes direction. That's very clearly going to be the second velocity graph right here. Let me explain a little bit more about why. This object begins with a large positive velocity and ends the first part of its journey with a very shallow curve. So it's steep and it gets shallower and shallower and shallower. And it's moving to the right, its position is increasing. So I need to have a velocity that is positive. Remember, velocity, positive and negative, just means direction, moving to the right, but getting less positive, approaching 0. That would be this right here. The velocity starts out as some large positive number and then reaches 0. And then for the second part of this object's journey, it's going to have a negative velocity, starting out very shallow and then getting steeper and steeper and steeper. So a negative velocity that is increasing, getting more and more negative, speeding up in the negative direction. So I would have this here, getting more and more negative, speeding up in the negative direction. That makes perfect sense. Let's look at this one. This one's pretty simple. This just shows an object starting behind the origin and moving in a positive direction to the origin. Is it speeding up? Is it slowing down? No. How do I know? Because this is not curved. It's a straight line. There's one slope everywhere. And so that one is going to match very clearly with this one. This object starts away from the origin and moves back to the origin, going in a positive direction. And so the velocity is one positive number. The velocity does not change because this is not curved. Let's look at the last one. This is probably the most complicated example. We know by our process of elimination that it's going to be matched up with that. Let's see if we can figure this out. Once again, maybe it would be helpful to kind of split this up into two. So I'm going to split it kind of down the middle here. Split this down the middle. Let's look at the first part of this object's journey. The first part of its journey, it has a positive velocity because its position is increasing. It starts out shallow and it ends up steep. Shallow to steep. So I need a small positive velocity ending with a large positive velocity. That's exactly what this shows. A small positive velocity ending with a large positive velocity. Right here in the middle, does it change directions? No. This object is still moving up and to the right. The slope of this is still positive. This velocity graph has only positive values, values that are greater than 0. It doesn't dip down into the negative like this one did when this object was moving back down, back to the origin. Its position was decreasing. This object's position is still increasing. But now what's it doing? Now it's going from very steep and it's getting more and more and more shallow. So while the velocity is still positive, it is getting less and less positive. It's becoming a smaller and smaller positive velocity, just